Okay, our last free response question. A serum cholesterol level above 250 milligrams per deciliter, mg per dl, of blood is a risk factor for cardiovascular disease in humans. At a medical center in St. Louis, a study to test the effectiveness of a new cholesterol-lowering drug was conducted. 100 people with cholesterol levels between 250 milligrams per deciliter, and 300 milligrams per deciliter were available for the study. So 50 people were assigned at random to each of the two treatment groups. One group received the standard cholesterol-lowering medication, and the other group received the new drug. After taking the drug for 3 weeks, the 50 subjects who received the standard treatment had a mean decrease in cholesterol level of 10 milligrams per deciliter with a standard deviation of 8 milligrams per deciliter. And the 50 subjects who received the new drug had a mean decrease of 18 with a standard deviation of 12. So we want to construct and interpret a 95% confidence that should say interval. So I'm going to change that here because that is a typo. Interval. Not that that means much right now. For the mean difference and decrease. And it got cut off there, but you get the idea. So 95, this is going to be a 2-sample T because we're talking about mean. We got 2 means here. Each person it's not a paired because it's 2 separate groups. It's not like one person's taking both drugs. So it's 2 separate groups, so it's not a pair. 2-sample T interval for the difference. Define the difference. We're talking the true difference in mean decrease in cholesterol level between the standard drug and the new drug. So standard minus new. So we're looking for a positive outcome. I say 95% confidence, even though it says that. You don't have to write that, but it's just kind of there. And let's check our conditions. This one doesn't say the conditions have been met, so we got to go up and check them. So let's talk about random. We do have random assignment. We have to say both groups are randomly assigned. And it says that right up there. Second one. Each group is 50. We would have to assume that that's less than 10% of all people taking the standard or the new drug. And then finally, because of our large sample size, 50 is greater than or equal to 30, we've met the central limit theorem, so our sampling distributions will be approximately normal. So we're ready to run the test, the interval. So let's go in our calculator and do that. Stat, tests, 2-samp T interval. That should be option 0. Go to stats, and let's throw the numbers in. So we have our S is 10, 8, and 50. So actually the direction I'm doing that's going to give us a negative number. That's okay though. Then the other one would be for the new one, 18, 12, and 50. And it says 95% confidence. Leave the pooled alone, click calculate. And here's all our data. So let's go ahead and report that. So when we're reporting that, we say, we get our results. We say just right from technology using the calculator, we're going to spit out some numbers. So we have our 95% confidence interval between negative 12.06, negative 3.945. You report that degree of freedom. You don't have to worry about doing the conservative degree of freedom. Just report the one that's listed there, 85.37. And then make a conclusion. What's our summary? Well, we would say we are 95% confident that the interval between negative 12.06 to negative 3.945 milligrams per deciliter captures the true difference in mean decrease in cholesterol for the standard versus the new drug. And finally, interpret the confidence level of 95% in context. Now, I've had some people have issues with interpreting a confidence level. So remember, it's not the same as this. Confidence level is if you had all the possible different intervals that you constructed using the same sampling procedures, 95% of those intervals would capture the true parameter, the true mean difference in this case. In repeated sampling of size 50, about 95% of all intervals calculated capture the true difference in mean decrease in cholesterol for the standard and the new drug.